Good day, guys. I hope you guys are good and you guys are well. Now we are looking into sequences and series. Grade 12 work. So we're gonna have like short videos. So as we begin now, let's start by looking at the revision of quadratic sequence, which was done in grade 11. So what is important is to understand what is a quadratic sequence. So we know that a quadratic sequence is a sequence that has a constant second difference. So we know that it has a constant second difference. So from that point now, this is the key which is guiding us to understand what's happening in this specific sequence. So e.g., if we can say that show that the sequence, just think of something first. Let's say the sequence is 1 is to 4 is to 9 is to 16 is to 25. Then they say show that this is quadratic. Show that the sequence which is 1 is to 4 is to 9 is 16 25 is a quadratic. How do you show that? We can show that this is a quadratic sequence only by determining the second difference. And how do you do that? Again, we are looking into this difference. So this is going to be your term number 1. This is your term number 2, term 3, term 4, term 5, and as we proceed going forward, term 6 and term 7. So in order for us to find the difference between the two terms, it's always the T2 minus T1, T3 minus T2, T4 minus T3. So that will be 4 minus 1, which is your T2 minus T1. Not T1 minus T2. No, 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 no. But it's T2 minus T1. So that will be 4 minus 1, which is 3. Then again, T3 minus T2. So this will be for T3 minus T2. So that will be 9 minus 4. That's going to give you your 5. Let's write properly. This is 3 and this is 5. Then again, 16 minus 9. Again, that will be your T4 minus your T3. So that's 16 minus 9. That's going to give you 7. Then again, the term which is in front minus the previous term. So that will be T5 minus T4, which is 25 minus 16. That will give you 9. So we can see that this is your first difference. But we say that in order for us to prove that this is a quadratic equation sequence, it has to have a second constant difference. So now let's look for the second constant difference. So we can see that 5 minus 3 is 2, because we say that the term in front minus the previous term. So that will be 5 minus 3, which is 2. Then again, 7 minus 5 is 2. 9 minus 7 is also 2. So we can see that this is our second difference which we have here. So on this second difference, we can see that the second difference which we have is constant. So therefore, we can now confirm that this is a quadratic equation. So if we still remember again, I think we'll focus more on it as we proceed. If you remember, we know that this first difference of a quadratic equation, it forms a linear sequence, which we know as the arithmetic progression or arithmetic sequence. So now that we know that this is a quadratic equation and a quadratic sequence, and a quadratic sequence as the second constant difference, now we can now be able to calculate or find what we call the general formula or the general term. So the general term has a specific formula. Okay, so the general term has a specific formula which can be written as the following. So that would be your Tn is equal to an squared plus bn plus c. Of course, we know that where your a value, your b value, and your c value are the element of real numbers. So in other words, now this is your general term. Now that we know that this is our general term, we need to know how do we calculate the value of a, the value of b, and the value of c, which is just easy and straightforward. And how do we do that? We know that we can calculate our value of a, we can calculate our value of b, and we can also calculate our value of c using these following equations, which I'm going to show you. It's just straightforward and it's just easy as it is. So in order for us to calculate the value of a, we know that 2a is equal to d. Then you make your a the subject of the formula, which means then your a will be equal to d over 2. What is your d? Your d is your second constant difference. which we have calculated just here. Then now, in order for us to calculate the b value, how do we do that? So that will be number 2. So in order for us to calculate the b value is calculated by saying 3a plus b is equal to term 2 minus term 1. Then after that, you make b the subject of the formula. So b will now be equal to your t2 minus t1 minus your 3a. Already, you've already calculated the value of a here by saying a is equal to the constant difference divided by 2. Then now you can just plug in the value of a there, then you can get the value of b there. Now, in order for us to get c, that's easy. Number 3, we get c by saying a plus b plus c is equal to term number 1. Which is term number 1? Term number 1 is this first term which we're given here, which we have on that specific position. So now we can be able to calculate the value of c, and we can make c the subject of the formula. Then your c will be equal to t1 minus your a minus your b, because your a you have already calculated it from point number 1, your b you calculated it on point number 2, and your c is what you're calculating for the third time. Now on the next small video, we will have our specific example to prove and solve questions based on quadratic sequence. Dango.